So let's go through this one then. So you've got z is equal to 10 plus 4i. Z is equal to 10 plus 4i. And you've been asked to calculate z squared. So can you remember how to do this? Any ideas? So this is using something called de Moivre's theorem. Can anybody remember, if you take a complex number and you raise it to the power of n, what should that be equal to?
Yeah,
good.
Cos n pi n theta.
N theta, excellent.
Plus I sin theta, n theta.
N theta, absolutely right. Okay, where r is equal to the
X squared plus y squared root under root.
Okay, good. So r is equal to x squared plus y squared square rooted, and theta is equal to
Tan inverse p by b. That means
tan inverse of.
p by b perpendicular means y by 4 by 10.
Okay, so in this case, y divided by x. Okay, yeah. So in other words, if you get given a complex number in Cartesian form, in other words, a real plus some multiple of an imaginary, then if you want to calculate z squared, you need to put it into polar form. Is this okay? You need to put it into polar form. So what would this thing be in polar form? In other words, what is my modulus and what is my argument? So what's my r? Just use this formula.
10 squared plus 4, 116.
Square rooted, yeah, good. So it's the square root of 116. Okay, so that's what r is equal to. What about theta? It's just the tan inverse of my imaginary divided by my real. So 4 divided by 10. What would this thing be in radians? 0.38 radians. Okay, good. Which means then that if I wanted to write this in polar form, what would it be?
Polar form?
Yeah?
Yeah, root under 16.
Good, so root 116, that's my modulus, multiplied by cos,
0.38.
good, 0.38 radians, plus
I sin 0.36.
I sine 0.38 radians. Absolutely right. So that's it in polar form. Now I can apply de Moivre's theorem to this to find z squared. So it tells me then that I should take my modulus and I should raise it to the power of 2. That's literally what it says. So I should take root 116 and raise it to the power of 2. Then I do cos of n times my argument. So n times is 2 times 0.38 plus I sine of 2 times 0.38. Okay, good. And then you can go through and tidy it up. So would you be happy this would be equal to 116 times by the cosine of 0.76 plus I sine of 0.76 radians. Okay? Now, if I asked you to convert this back into the form you were given it in, so if I asked you to convert it back into Cartesian form, how would you do that? So how do you go from polar form back into Cartesian form? In other words, some real part plus some multiple of an imaginary part. I would start by multiplying this out. Okay? Sorry? So I'd multiply through by 116. So in other words, I would get 116 times by the cosine of 0.76 radians plus I times by 116 multiplied by the sine of 0.76 radians. Okay? So now I've multiplied it out. Would you be happy that I have a real part? That's my real part. And I have an imaginary part. That is my imaginary part. So in which case then, all I need to do is stick that into a calculator and it will give me a number. Okay? That's all that's happened here. You've just simply multiplied this out to convert it back into Cartesian form, you just find out what that is equal to and what that is equal to. You're happy that corresponds to that, and that corresponds to that. Okay? So that would be, if z is equal to 10 plus 4i, z squared is equal to 84 plus 80i. Is that okay? Like, that's just a revision of what we've been doing before. Yeah? Good.